Hello, you're welcome to Master T Math class. In this class, we want to look at this topic in mathematics, which is matrices and determinants. And let's start by looking at the outline of what we want to consider in this class. We have from here, we'll be looking at the definition, that is, what we mean by a matrix. Matrices is plural, and matrix, we have the singular. So what do we mean by matrix? Also, we look at the order of matrix. We have notation of matrix. We have also the types. We have types of matrices. Type of matrices. Then also we have addition and subtraction. Addition and subtraction of matrices. So let's look at all this for now. Now, when we say a matrix is a rectangular arrangement of numbers. So it's usually in row and column and enclosed within a large bracket. So we have arrangements of quantities, usually numbers, in rows and columns. In rows and columns, and usually enclosed within large brackets. For instance, let's look at an example here and say we have 513 2 4 minus 3. So we have this number arranged in rows and columns, and this is enclosed within a large bracket. So we can call this as a matrix. And a matrix has this matrix now, the example we have here has two rows. This is the first row, as we call it row 1, and this here we have row 2. The rows are the horizontal arrangement. So 513 here, that's row 1. 2 4 minus 3 here, that's row 2. Also we have this as a column 1. Column 1. Also here we have this as column 2. And here also we have this as column 3. So we have here 2 rows and 3 columns. So this is a perfect example of a matrix. So that's the definition. A quantity usually number arranged in rows and columns enclosed within a large bracket. And there is something called, now we are done with definition. Now to the order of matrix. Order. The word order means arrangement. When something is orderly arranged. In Cartesian plane, we discover that when we have our plane in Cartesian planes, which is x and y, we have something called ordered pair as well. Ordered pair. And here, for Cartesian plane, it's usually x first before y. So whatever point you want to plot under the Cartesian plane here, it usually comes as x first, then y second. And also under matrix as well, the order of a matrix is usually row by column. Row comes first before column. All right. So generally, we want to state the order of any matrix. There is need for us to mention the row first before the column. For instance, here, this matrix above has 2 rows and 3 columns. So from the above example, above, we can say that the order of that matrix is equals to, the order implies we have order 2 by 3. This 2 is representing the row, while this 3 is representing the column. So that's the order of a matrix. For instance, we can give another example of a matrix and tell the order. So let's have a matrix. Let's say we have 3, 0, 2. Okay. We have 4, 3, 1. Then 5, 2, then minus 3. So this is a matrix. This matrix has how many rows? The rows and the horizontal, it has 1, 2, 3. So it has 3 rows. So we are going to write 3 for it. So the order of this matrix is 3 by the column. Also we have 1, 2, 3. It has 3. That's 3 by 3 column. Matrix. And we call this one as a square matrix. So we are coming back to the type of matrix anyway. So we're going to see that there. So we call this a 3 by 3 matrix. Now, what if I clean this and have this left? What is the order of this matrix here? And you discover that here now we have how many rows? We have 1, 2, 3. 3 rows, that's 3 by how many columns? 1, 2. That's 3 by 2. And so on and so forth. So that's the order of a matrix. Is usually in row by column. Alright. Then let's move to the notation of a matrix. Talk about the notation of a matrix. Matrix is usually denoted in capital letters. When we have a matrix, we represent matrix with capital letters. So we use capital letter for matrices. For instance, if I want to label a matrix and I have matrix A, and this here we can call it, you can say matrix A, we have 1, minus 3, 0, 2, 4, minus 4. Now here in this matrix, the notation for this matrix denoted with a capital letter, and the element inside it is denoted in small letter. Now what this one means is that we have matrix A which contain this element. We have 2 rows here. We have the row 1, row 2, that's 2 by column, that's 1, 2, 3, 2 by 3. Now for here, if I want to write this as the element using small letter A, I can say A11. Now we should understand what A11 means. And also here we have A12, A13. Now let me explain what this subscript means. We talk about order. Order in matrix, we write the first number should be row, the second is column. Now A11 here means the first one here is the row, the second one here is column. So it means the element in row 1, column 1. And when you look at it, this one is the element in row 1 and a column 1. And here means the element in row 1, column 2. This one stands for row, 2 here stands for column. So element in row 1, column 2. Okay, so minus 3 here is the element in row 1 and column 2. Also, we have element in row 1, column 3, the first row and the third column. And that element here is 0. That's row 1, column 3. And here, this will be A21. This one means element in row 2, column 1, and that's 2. Here we have A22. This one means element in row 2, column 2. Here we have A23. Element in row 2, column 3. That's minus 4 here. Now, I believe we understand what we mean by each of these. Now, this subscript means something, especially when we see it like this. The first one standing for the row, the second one for the column. Alright, so we might be asked to solve this question based on what you have learned. On this definition order notation, we might say consider this as an exercise, and we say let A, or given that matrix A is equals to 1, 0, minus 2, 3, 4, minus 5. So we have this as matrix A, and also we have matrix B, and this is given as 5, minus 3, minus 4, and 2. So here we have matrix B. And the question says we should determine the following. A now, the order of A and B. So what's the order of matrix A and B? And question B says determine 1, A 1 2, 2, A 2 2, 3, A 3 2, 4, B 1 1, and 5, B 4 1. Now from here, when we look at this, so we can do the solution, or we can do the solve it up here together. So when we look at this problem given to us, easily we determine the order since we know the meaning of order of a matrix. So we can say that for question here, we have the order of matrix A. Order of A is what? Order, the row come first. How many rows? We have 3 rows by how many columns? 2 columns. So that's 3 by 2. That's order of A. Then order of matrix B is how many rows? Look at it. We have 1, 2, 3, 4. 4 by how many columns? Just 1 column. 4 by 1. That is that. Then for question B, Roman figure 1, A12 means element in row 1, column 2 of matrix A, because it's small letter A. Now look at matrix A. Which element is in row 1, column 2? This is row 1, this is column 2. The element here is 0, so we have 0. And question 2, we have A22. This element in matrix A, which is in row 2, column 2. Don't forget we have the row 2, so second row 2, column 2. So that element here, which is in row 2, column 2, that's 3. I believe we are getting that. It's very easy. Okay, so the third one also we have A32. So that is also element in matrix A, which is in third row. No row come first. Row 3, column 2. Row 3, column 2. Yeah, that's minus 5. Then Roman figure 4, which is B11. This is element in matrix B now, which is in row 1 column 1. Row 1 column 1. That's 5. And number 5, we have B41, which is element in row 4 column 1. Just add 1 column. So row 4, that's 2. So we have 2 here. So that is that. Once we are able to do this, we have already set the tone for our matrices. So when we are talking about something, we're able to know that, oh, this is the element they are referring to. And that is that for the definition, for the notation, for the order of a matrix. Now, let's quickly look at the types of matrices that we have. We have some types of matrices. So, do well to give a thumbs up to this video. Subscribe to Master Team at Class. Thank you. Alright, now we have types of matrices. So we need to be familiar with these types of matrices because we'll be needing them in solving problems as we go on. The first one we look at is a row matrix. And as the name implies, a row matrix, a matrix with just one row of elements. From the word a row, has only one row of elements, e.g., we can have matrix 1, 4, 6. This matrix has just one row of elements. It has just one row of elements. So we can say, the order of this matrix, since it is one row, it will not be having order 1 by how many columns now? 3. So this is order 1 by 3. 1 row, 3 columns. So that's a row matrix. 2, we have a column matrix. A column matrix. So once we know what a row matrix is, a column matrix is also following the same thing. It has just one column of element. Just one column of element. E.g., we having just something like 2, 5. This matrix now is having just one column, but how many rows? 2 rows. This is the first row, second row. So the order here, row come first. We now say we have order 2 by 1. So 2 rows, 1 column. And next, we have what is called zero or null matrix. We have 0 or null matrix. Now, for this type of matrix, all the elements inside the matrix are zeros. So, are zeros. So, we have all the elements 0. E.g., when we have matrix and we have 0, 0, 0, 0, all the elements inside this matrix are all 0. So, we call that type of matrix a 0 or a null matrix. Now, next, we also have what is called a square. A square matrix. A square matrix. This type of matrix has equal number of rows and columns. The number of rows and columns are equal. E.g., we can say we have matrix 1, 3, minus 2, 7. So this has 2 rows and 2 columns. We call it 2 by 2, which is a square matrix. We can also have a 3 by 3. E.g., we can have the second example for 3 by 3. We have 1, 0, 4, 4, 3, 6, 8, 7, 2. This matrix has 3 rows. 1, 2, 3. And also have 3 columns. 1, 2, 3. So this is a 3 by 3 matrix. We call this square matrix. So that's number 4. Then number 5, also we have what is called a diagonal matrix. A diagonal matrix. Let's clean number 1 since we have seen that. Okay. So number 3 here. Do it to watch this video today. Give a thumbs up. Share this video. Subscribe. So we have what is called a diagonal. A diagonal matrix. From the word diagonal, it contains the elements only in the leading diagonal. Or in other words, this is a square matrix whose elements are all zeros except those in the leading diagonal. So when we talk about diagonal matrix, it's a square matrix and it has all the elements zeros except those one in the leading diagonal. Let's look at the example. Here we have something like 2, 0, 0, 0, 1, 0, 0, 0, minus 4. This is a private example of a diagonal matrix. This is what we mean by leading diagonal. On the top left down. So this is a diagonal. Now, all these elements are not zeros. So this is a 3 by 3 matrix. That's why we say it's a square matrix, which the leading diagonal is what we only have number. The rest are zeros. So next, that the similar to this, we have a unit matrix. A unit matrix, or we can somehow call it identity, or we call it identity matrix. So this is a diagonal matrix whose elements in the leading diagonal are all 1. On the word unit are all 1. For instance, we can change this and we have 1, 0, 0, 0, 1, 0, 0, 0, 1. So all the elements in the leading diagonal here are all 1. So we call it identity matrix of a 3 by 3 matrix. If it's a 2 by 2 matrix, we are going to have 1, 0, 0, 1. So this is identity matrix. And sometimes it is denoted by I. So we say I equals to this. So it depends on which I we are talking about. It might be for a 2 by 2, or it might be for a 3 by 3 matrix. Thank you for watching this video. So that is the type of matrix we have. And okay, let's look at the next point here, which is addition and subtraction of matrices. Addition and subtraction of matrices. We have addition and subtraction of matrices. Okay, for this here, let's consider 2 matrices, which are matrices A and B. So we are going to use this as the general way of adding and subtracting. Let's say matrix A, we have a 2 by 2 of A11, A12, A21, A22. And also we have a matrix B, which is B11, B12, B21, B22. Okay? Then, when we have A plus B will just be A11, A12, A21, A22 plus B now, which is B11, B12, B21, B22. And we'll call something corresponding elements. So we are going to add the corresponding elements here together. A11 is corresponding to B11. So we say A11 plus B11. Whatever